Welcome, Solidworks community, to the final part of our three-part series where I'm running through designing and building a custom refrigerator juice dispenser. In part 2 of the series, we completed the design of the plastic components, but this is a pretty large part at about 13 inches wide by 15 inches tall, so we need to split these components into smaller segments for desktop 3D printing. To easily split the parts, I'll sketch on the front plane and just draw a few lines to use for the split operation, making sure the lines protrude outside of the part. Exit the sketch, and with the sketch highlighted, navigate to Insert, Features, Split, click the Cut Bodies button, and select the bodies you'd like to split. In this case, we want to make sure the Consume Cut Bodies option is not checked. Now, to help line these segments up perfectly during assembly, we need to add some alignment aids. We have a few options here. We can either build in some sort of alignment aid like a lip and groove, or some sort of puzzle piece design. But to me, the easiest thing to do is to cut small holes in the joining faces of the segments, and use small diameter off-the-shelf plastic dowel pins to align the parts. These dowel pins can be purchased from a supplier like McMaster Carr, and I'm using 1/16 inch diameter by 3/8 inch long acetal pegs. So I'll just run through the parts and cut 1/16 inch holes throughout the adjoining faces. Now with our design split and the segments designed to join together, we're ready to head to the printers. I was able to print all of these parts in parallel on 5 large desktop 3D printers with an 8 inch by 10 inch by 8 inch print volume. And I printed the small internal clips on a smaller desktop machine. After unloading the parts and removing the support material, I head to the workshop to assemble and finish the parts. Using the plastic dowel pins I purchased from McMaster Carr, I'm using super glue to glue the components together. Prior to gluing the segments together, I'll make sure to sand the adjoining faces to ensure as nice of a joint seam as possible. And I'll simply step and repeat to join all of the segments together. With all the parts assembled, it's time to sand, and sand, and sand some more. And as you'll see, I'm just sanding the exposed faces of the dispenser to save time and energy. After sanding, I'll use some Bondo Auto Body filler to fill in the seams where the dispenser segments came together. After filling the seams and sanding away the excess body filler, we're ready for primer and paint. I'm priming with a filler primer which will fill some of the small imperfections in the print. After sanding the filler primer coat, I'm painting the dispenser with a gloss white, and I'll finish up the paint job with a clear coat. With the components assembled and painted, I'm ready to solder the electrical components. I've sketched out a diagram in case you'd like to duplicate how to solder together the components. You'll need push buttons, miniature air pump motors, a 9-volt battery lead, some red and black electrical wire, and a 9-volt battery. You'll find links to where you can purchase all of these components in case you want to duplicate this design. And here I've also used some heat shrink tubing to make sure the soldered wires aren't exposed. It should be noted that I had to solder the leads onto the buttons first, assemble the buttons onto the dispenser, and then complete soldering the rest of the leads to the air pump motors and the 9-volt battery lead. I'm wrapping up the system setup using the plastic screw caps from the juice containers I've chosen to use, as well as 2 tubes. A smaller 9/32 inch outside diameter and a larger 1/2 inch outside diameter food grade PVC tubing. Drill 2 holes into the cap and ream them out to match the 2 diameters of the tubing. The liquid will be dispensed through the larger diameter tubing, so it will run all the way to the bottom of the bottle, and the other end of the large tubing will be run through the exit hole on the dispenser. The small diameter tubing protrudes into the bottle cap slightly, maybe 1/4 of an inch, and then the other end is attached to the air pump motor. Prior to connecting the ends of the tubes, make sure to seal the connection between the tubes and the plastic cap using some clear silicone. This will create an airtight seal and allow the system to work. So essentially the motor is pumping air into the juice bottle, and the pressure that builds up in the bottle forces the liquid out of the larger tube and into your glass. With the system complete, I've dropped the dispenser into my fridge, adding some dry erase tape labels, and the kids are ready to help themselves. We hope you've enjoyed this 3-part series and that you've walked away with a few Solidworks pointers, as well as a few tips on 3D printing and finishing larger components. Thanks for watching, Solidworks users, and happy juicing!